Section 2.7, page 2. Now we'll go ahead and look at example 3. So the question reads, a ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at the rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So when possible, we have our visual, right? So I've got this ladder leaning against the wall and it's sliding this way. And although we've got this current height against the wall, as it's sliding down the ground, we know that it's slipping further and further, and we want to figure out what this height is. So it starts off stating a ladder is 10 feet long. A ladder is 10 feet long, and that's our hypotenuse in this case. So thinking of a right triangle and using the Pythagorean theorem, our hypotenuse is 10 squared or 100. And next it says the bottom of the ladder slides away from the wall at a rate of 1 foot per second. So here's the bottom of the ladder and it's sliding along the wall. But because it says at a rate of 1 foot per second, x isn't 1, but instead the derivative of x, which is the derivative in terms of time, dx dt, is 1. And then it ends with, although it asks for how fast, it ends with when the bottom of the ladder is 6 feet from the wall. So when the bottom of the ladder is 6 feet from the wall, this is going to be our x distance of 6. So the question asks about the top of the ladder. The top of the ladder is whatever this y height is. So we're looking at y, but it doesn't ask what is the height on the wall. It has how fast is it sliding down, meaning that the rate of change of y is what we want, and because it's sliding down, we're expecting a negative answer, as you can see we got. So the only equation we have is this right triangle from our picture, x squared plus y squared equals 10 squared, because we have a right angle. So I'm going to take the derivative of each term based on t. The derivative of x squared is 2x, but I need to put a dx dt. The derivative of y squared is 2y, but I need to put a dy dt. We're given the hypotenuse, and the derivative of any constant is 0. Now, I want dy dt, but as we kept doing, instead of solving for it now, let's plug in the values we're given. We had determined that x was 6, and dx dt was 1. Now, this gives me this line, and obviously I can multiply the 2 and the 6 to get a 12, but the problem is, when I look at 2y times dy dt, I still have two unknowns. So we can't solve for dy dt until we have a value for y. But we can figure out what y is. If x squared plus y squared equals 10 squared, and we know what x is, then really we have 6 squared, which is 36, that can be subtracted to the other side, where 10 squared was 100. And we just have y squared is 64. Taking the square root of both sides, we end up with y is 8. Now, true, it's plus or minus 8, but since we're talking about the height of where the ladder started, it can't obviously start at negative 8 feet on the wall. So, going back to this equation, where y is, I can go ahead and insert the 8. So 2 times 6 times 1 is 12. 2 times 8 is 16, but it's multiplied by dy dt. So dividing both sides by 16 gives me the rate the ladder is sliding down the wall is negative 12/16. But I do need to divide top and bottom by 4 so that I have negative 3/4. In terms of units, remember what does y represent? Y represents the height of the ladder, and the height is measured in feet. And what is time being measured in? According to the question, time is measured in seconds, so we have per second.